inputs or laboratory inputs. There can be data shifts between the training part of artificial intelligence and the real-time working of data. There can be unexpected variants in clinical contexts or into laboratory contexts. Those can be translated into medical consequences, and I've listed you there the measures and the medical consequences. But clearly I think that if we are discussing the future digital or digital future of medicine, as the WHO representative discussed with us today, I think we have also to solve these issues, because otherwise we will be in the area of science fiction, and you know, in that area sometimes robots actually took a negative path, and that is actually very nicely underlined in this document. This is, as you see, a European Union vision. This is a proposed multi-stage approach to the development of medical algorithms, and there are several steps of evaluation, from feasibility pilot studies and then going to implementation. And you can see this document, and I think that more documents are going to appear to sort of discuss this area. In the second part, I'm going to discuss another very interesting part and very challenging for you, and I hope that I'm really shaking the tree at the beginning of this conference. I'm going to discuss about digital medicine, exactly what was proposed this morning. I bear in mind that I didn't know the program before, and I didn't know about what your guests are going to discuss. Great minds are sometimes coming alongside, and I'm going to introduce something which is closer to the concept of the young researchers, and I hope that I'm discussing your language here, which is the metaverse. This is one presentation showing that everybody should join into the metaverse, which is the virtual reality of big tech. And in fact, some experts are really enthusiastic, and they are now even proposing some consensus expert conferences and meetings and documents of the metaverse in medicine. I think we are going a little bit too fast here, because first of all, I think that we have to translate what is the metaverse. Otherwise, we are going to discuss about things which we don't really understand. And if we look at the metaverse as a healthcare concept, this started to gain traction in 2021, and it was widely discussed. Of course, that it was discussed in 2021 because with the pandemic and the COVID, everybody was into a digital area. We were not doing proper medicine, for example, or proper real-life, let's say, interactions. And basically it refers to the internet access via VR and via augmented reality. And these are devices, and this is a scheme, but in fact you all know, and you've heard, and you've seen, some of these VR devices are actually working today, and they are becoming better and better. The metaverse as a digital world was established on the basis of medical technology, and this idea actually originated from a novel. This is why I've mentioned science fiction. Sometimes science fiction or those fiction novels are programmatic. Remember that the word robot was actually invented by Isaac Asimov. And Professor Werner was an American mathematician, and he published a story in 1981, and the author conceived a really virtual world in which we are going to live, and we enter and obtain sensory experience throughout a brain-computer interface. And then the name of metaverse was coined again by an American science fiction writer. Probably by now you are going to think, Professor COVIC, you are discussing with us only science fiction. No, I'm discussing what is now becoming real medicine. And as a concept, the dynamic process of the meta-medicine will be constructed to make the virtual world approach the natural world, the real world, into minute detail, into infinite detail. And the technology will be more and more developed, so that in fact we are going to capture in real time throughout a multi-sensor device any information and all those interactions. And you've heard about digital avatars and how these are going to modify our approach. This is again a scheme, but this is a scheme which is already in practice today, and I'll show you more data about that just in a moment. In fact, that scheme shows that in an outpatient setting or in any setting, a surgical theater, for example, a doctor can communicate with a patient, with his team, by wearing extended reality device, it's now called, and through real-time identification, tracking, all this information, all this interaction will be retrieved and disseminated and presented and superimposed on reality. And in fact, this is the point, will form clearly a new relationship into a new natural environment. So if we look at the meta-medicine now, let's call it meta-medicine, there is an interaction of all things. There is an integration of virtual and real, and it's a full decentralization. Let me discuss about the last part. I'm sure that some of you, particularly again the young researchers, doctors here in the audience, have some experience with that. There is the blockchain technology, which is involved already in the certification, authentication of all rights. So you know, for example, that you can buy now land in the metaverse, and this is exactly like a transaction in real world, and this is through this blockchain technology. And this is the sort of network, and you can see that we need for sure something which is close to the 5G, which means a very powerful internet network. We need cloud computing, and not only cloud computing. We need this blockchain technology to authenticate everything, to be, in fact, to label everything. And for those of you which are working into laboratories, you know how important it is to label everything and to have a perfect chain of authentication. I've discussed about extended reality technology, and I've discussed with you in the first part about artificial intelligence. So now you have all the pieces of the puzzle, of the Lego, of the big Lego, which is expecting us in the near future. Now, before trying to show you that those are not simple concepts, but in fact, as in the first part with studies, I'm going to show you the real world, that the future is now with us, even in maybe next door. This is again from my town, a wonderful university city. This is the Palace of Culture, and this is a modern neo-Gothic style. Iași is really full of architectural gems. And of course we are very proud of those, and I think that we expect you in Iași whenever you have the pleasure to come and see us. Now, the real world. So what are the potentials of metaverse in the healthcare? First, VR in the growing role of medical training. How can we do that? Here are some few directions. The trainee can have a closer view to, for example, to the surgical procedure. He can feel what the surgeon feels inside the body. Exams can be verified through video recordings, through practice procedures, and we can have interactive module as well. This is, for example, how an examination with students could be in the future. And I've told you that we have now, this is real life. This is the Oxford Medical Simulation book and procedure. So it's not, we are not discussing, let's say, science fiction. We are discussing a proper procedure which is now implemented. And let me show you this, this movie, please. Rulează. I'm not sure if you see what I see. You don't, probably. Basically, I'm trying to describe, this is an anatomy lesson. Să mergem mai departe. This was an anatomy lesson, in fact, in which actually you could see inside the body, inside the tissues, inside everything, and then make correlations with other data related to that. So, in a way, it's the future of teaching anatomy. It's the future of teaching surgical skills. And I'm making, usually when I'm discussing with colleagues and friends at big conferences, I'm making bets. And usually I'm right, 90% I'm right. I bet you that in 5 years, the teaching of these areas will be completely different, and there will be a revolution throughout this new educational skills. What are the other potential metaverse in healthcare medicine? The therapeutic application of the metaverse. The VR technology can enable application for cognitive therapy. We have a research grant for that. There are support groups for evaluation and rehabilitation, which can, with the sensor, with the haptic sensor and physical therapy, they can improve that. There is a famous study in which patients were divided into 2 parts. One group, it was a randomized controlled trial. First group, which was the control group, patients were doing typical standard physical rehabilitation. The other group, they were doing only the VR enhanced rehabilitation. They were just sitting in their, let's say, in their chair. Guess what? At the end, there was no difference between the 2 groups in improving functional, cognitive, laboratory parameters. In the VR group, actually, parameters, lab parameters, were equally improved as in the physical training group. Then telemedicine is in fact a derivative of that. There was a surge in popularity after the COVID pandemic, because in the COVID pandemic, telemedicine became the norm in many countries. So now we know how to do that. We know how a patient can pay for that. We know how a patient can actually send the data. Telemedicine is already a major gain from the COVID pandemic. Patients are no longer limited to treatment or to consulting by particular physicians. Scans and tests which are carried everywhere in a facility can be directed everywhere. For example, here between Romania and Moldova, we can think of a common telemedicine consultation hub, which can take advantage of the best specialists from across the region, or we can actually have this across the region. And we can actually develop this throughout the end. Then there is the augmented reality in surgical procedures. And the surgeon will meet in a virtual operating theater, beforehand, surgeon will have on their display, like the pilots, that's already in there. All the data, they are performing the procedure, but they can have the data, scans, different parameters of the patient and so on. There would be new integration of the technology and real-time and rapid results for better patient outcomes. So in fact, if I summarize all this part, there are three areas in which this highly science fiction maybe part is already there, and I think will likely dominate. Surgical operation, mental health and mental rehabilitation and physical rehabilitation, and for sure medical training and medical education. This is me. Imagine that this is me talking to you in the future. I could be in Iași, in my office, and I could discuss with you the same thing, and I could see the interaction, and it's not really online. But I think it has many promises, but also many dangers, and I think that this is a proper, let's say, invitation to think of that, to discuss that, this fantastic forum, regional forum, biotechnology, and although this is not strictly central biotechnology, this is the basis for any biotechnology. And thank you very much for the invitation to talk with you and share my thoughts.
Dear colleagues, do you have any questions? No?
Please.
Thank you so much, Professor Prof. It was an amazing, really amazing lecture. It was great for you to hear about the picture because of our university, also based on artificial intelligence. We found some predictors to predict after fibrillation. So I really can appreciate the results you explain about and thinking about understand maybe we will have because we all know that some of the predictors for the appearance of the recurrence is good, but to predict the sinus wave, this was amazing for you. And I have two questions. Which methods of artificial intelligence did you apply therefore? And the second question is whether you have maybe some interest to cooperate with our team to make some common projects maybe about this issue.
I'll start with the second part. I think this is, thank you for the comments and appreciations and questions. The second part, I think this is my invitation because you've seen there that the first layer of any artificial intelligence and metaverse and so on is actually huge amounts of data. Huge amounts of data which should be shared transparently and not be the ownership of somebody or only some team. And I think that Moldova and Romania, also because of the language, and not only because of the language, historical ties, I didn't want to shake the trees, but Iași, the beautiful city which you've seen, is in fact the historical capital of Moldova. We are merely divided by times. I'm sure that we are going to be together sometime. Enough for the political comments. Coming back, we need large amounts of data. So we need to put together large amounts of groups. So I think it's ideally to have similar protocols, discussed protocols, and actually to apply those to different populations, clinical populations, lab populations, and so on. And then you are going to have the huge amounts of data which are relevant for artificial intelligence. Otherwise, to come back to your first question, in fact, any small, let's say, item which is found by a machine learning algorithm or a deep learning algorithm or some other future approach is not going to be relevant or is not going to be discovered. So the first, in fact, advantage of this future is, if we understand it correctly, it is an invitation, and it will force us to cooperate and to collaborate through similar protocols and so on, and to share the data. And I think that although Europe has this vision, and it's good that it has the vision, it still lacks, we are still lacking behind the vision, and it's maybe a good time to fulfill the vision. You've asked me directly. We have a very interesting protocol by which we are using VR devices for dialysis patients for various research protocols, and we are now gathering the data, and of course if groups from Moldova would like to join, that would be fantastic, and we can apply for different grants as well.
Please.
Okay.
The first thing is about the clinical data. I'm absolutely agree that there are incredible amounts of data out there, but the quality of the data and how we assess them, it makes our research, garbage in and garbage out. If you put the wrong data and the quality of the data, you can do how we do that. And the second question is, the IT people, especially in artificial intelligence, speak completely different language as the doctors. So to communicate with each other, you need a translator, and people do better than that they have translated only. So how you deal with that? How you gather people? Do you have multiple people there and so on?
Okay, those are fantastic questions, and actually you've sort of told me that you are going to put dangerous and difficult questions. They are not dangerous and difficult, they are fantastic questions. Let me deal with both of them. The garbage in, garbage out concept is in fact not new. It is now clear, or even clearer, that it was there and it was purposely forgotten for the concept of evidence-based medicine. And evidence-based medicine is the past revolution in medicine and biotechnology. Because before that, we only had experts and, let's say, some small expertise. And then, through the evidence medicine-based concept, everything was next day change in the landscape of medicine and research, biotechnological research, because we had to do very sort of established studies, and the output of those studies were in fact determining how we manage, how we treat the patient, and so on. And in fact, garbage in, garbage out applies to that as well, because in evidence-based medicine, you can put everything you want and you have some results. And then if you manipulate those results, you can actually, let's say, join the wrong conclusions. And if we are correct with ourselves, we should be correct, particularly in Europe. The COVID pandemic was a blueprint for that, because it actually put a lot of garbage in, because we wanted rapid results, we wanted solutions, we wanted to act fast. There was a fantastic pressure. I'm not for one side or for the other side, but in fact we actually abandoned all these principles, and we actually put a lot of garbage in and we had a lot of garbage out, which we have to deal with of those consequences, and we can discuss here about all the issues, starting from isolation, masks, treatments, and so on. And I think this is a blueprint for what we should discuss in the future. So you are right. What is the solution for that? I think that the solution is honesty, like similarly to evidence-based medicine, and transparency. Because the issue with the evidence-based medicine, it was that transparency at some point disappeared. It should be complete democracy of the data. Of course, we are going to have some garbage in there, but if we have a critical approach and we are not refusing the critical approach and shutting down the critical approach, then I think we are going to have the Cerberus, the dog, which is going to bark that mistakes are done there. And we should not make an absolute of the data. We should actually always think of the data in the real context. That's the first part. The second part is actually even to me more clearer, and this is why I actually constructed this conference here. Because the simple answer is through education. When I approached this conference, actually I wasn't clear with some of the concepts. So I had to learn about those concepts. So the answer is that we should change our medical education programs. Instead of teaching, for example, stupid anatomy, sorry if there are anatomists in the room, which takes 2 or 3 semesters as a curriculum, we forget about that. Maybe we should compress that, and we should have other ways of learning that. And not anatomy, but all these new concepts. And of course that is going to be difficult. It's like learning a new language, for sure. But in university now, in some university, we conceive to learn Chinese because of the future of China, and so on. So I think that through these programs, and real life is going to teach us as well, we are going to be there, for sure. But for us, which are organizing, let's say the seniors, we have to be open to change and to let the change happen. And I think that this sort of conference is perfect for fostering the change in also this area. So I hope that I answer correctly your 2 very difficult questions. Perfect for me to give the same sort of talk in Graz. Thank you.
We greeting Professor COVIC for interesting and excellent report, and invite Dr. Roland Lapuk, Smart Technology Advisor to the President of Latvia. Please.
I think, yes, it works better. I think after this wonderful speech, I have to introduce myself and put me in the category that was mentioned, translator. Because I have, you were mentioning that metaverse was invented as a notion in 1981. That was when I was finishing my PhD at the University of Strasbourg in neurosciences. I spent 20 years linked with biology, then 23 years with the Latvian diplomacy. And when our state president invited me as an advisor in smart technologies, well, he had no idea about what I was going to do, and neither did I. So I went into what I knew, which is biology and medicine. And as you know, the way to metaverse is paved with good intentions, and on the way you forget to correct a few things. And so I found my role as trying to cope with the problem that you have on the way to metaverse. And but it is also our goal, so we'll have to talk a lot. It is clear that without data, there is no medicine anymore, and there is a lot, it was mentioned, data and wrong data, garbage has always existed, but now the quantity of it is tremendous. So you have the state has to come into that in order to not only better the quality, raise up the quality, but you have, for example, a simple issue of when you have big data. We were talking, you have sequence a genome, you have to do that 30 times, it's about a terabyte, and if you want to transport it, well, you need a good infrastructure, you need good servers, they have to be compatible, and so in Latvia I was also linked with the Genome Data Network. The two companies went into bettering the transportation of data from one science institution to another one, or from the main university hospitals to these science institutions, etc. Another thing that I have been and I'm still dealing with is a good infrastructure in legislation. So you need good, we have a biobank law in preparation, we have a law in for the secondary use of health data. Those are very important aspects. You were mentioning COVID, the COVID crisis. Yes, there was certainly at the beginning, I understand some Mr. Jan Sklovinch is more an expert, but one thing that was shown, and it has been mentioned this morning, the COVID crisis has shown that international cooperation is absolutely of highest importance, and that means cooperation means also the transfer of data. So this will be one aspect. The issue is also, unfortunately, that in order to be able to transport this data, it has to be in order at the national level. This is also what I am dealing with, and I've chosen a few themes in which I think I can help at making a difference. The state has to come with the right decisions. It's not easy. I was talking about the good intentions leading not to metaverse, but leading more to hell. For example, 5 years ago in Latvia, there was a strategical decision to give the responsibility of the oncological register, all the data, from the CP, this is the Center for Disease Prevention and Control, to the National Health Institute. It was a good decision, but some accompanying measures were not foreseen. It took a while, and then after, the medical doctors were not anymore introducing their data, and it stopped really working. So 2 years ago, there was a kind of a survey. I'll ask where? Here? And what do I do then? I'm an old man.
This is forward and this is backwards.
Okay. Experts were interviewed. What would they like to see in for their work in the medical field, especially linked with cancer data? So this survey, what you see here is what they would like to see. So they're kind of a paradise they are aiming at. And it's only logical to have good service qualities, to have good data in order to have good communication with the compliant patients, so you can be following the development of a disease as efficiency. And then in order to have a good national policy, well, you have to have a data-driven social healthcare policy. Only logical things. So, same, it didn't go further. No, sorry. Well, those are all the wishes of the medical staff. They were all wanting to have more prophylactic approach to things, preventions, etc. And you need data not only about patient you are curing, but also about the future patients, so to say. What are the challenges? Well, if you see the Latvian challenges that are here, I suppose they are quite similar to what you have in Moldova, I would say. You need to have, you were talking about quality of data, you need a good standardization in order also to have then a good transportation of the data. One of the problems is that there is a fragmentation of data storage. It's partly linked with the fact that when you are not, when you don't have enough financing, you choose to work with a company or with another company, and then you are actually stuck with some kind of software, and you stay with that depending on what the company will offer you. It leads to a health system, so you make an analysis, and then you go to another institution and you repeat the analysis. So there is a lot waste of time, waste of money, waste of capacity. Secondly, in the registers that you use in Latvia, it's sometimes very difficult to use them, to have the right approach to authorizations. We have, it's Ars Bureau, it's called, it's the system that is actually where you put the information, but it's not meant for, to give your information exchange with the, when we are talking about the flow of data, it's important. It's only PDF documents, so we had to renew all this. I don't want to go into details, but the system was old-fashioned, unfortunately. So you have then to react. The Ministry of Health was intending to have a new, totally new onco register. It's under process. We asked also for the support of the European Commission. It's a project financed by the DG Reform. And it is dealt with the, it was I think mentioned today, IARC, the International Agency for Research on Cancer. So we have the best experts, and there we have started this project. I'm co-chairing this project with the professor in medicine, and the aim is really to improve the cancer care coordination in Latvia. This means to actually, what it means is to have a decent flow of data. They have to be stored properly, high quality. They have to be given by the doctors at a high quality, but they have also to be accessible to others. They have to be able to be transported very, very easily. So we are, and I am involved myself in my life in this project. So you have three kinds of registry. The basic one is population-based for the screening, and the third one is a wider medical data register. But if you take one after the other, it doesn't work. And the issue here is to make them to integrate in the onco register also the information you will need for the screening. You can't repeat that. It has to be done parallelly. The public servants would like to have this in a sequence. Well, it doesn't work. This is now what is going, it is the scheme showing what is going to be the onco register in Latvia. You see the box in the middle, that's where the information comes with all the information, analysis, visual information comes from the laboratory through API, and it goes further. Now it is for the onco register, but there should be also something showing for the screening register. This is where we are working at. The first step will be until the end of the year. And my aim is to help at bringing this delegation to the right people and also to integrate the information so that it is supported also by, for example, the Ministry of Health. This is one, the ER comes with this, for example, organigram You have the Ministry of Health, the National Screening Board Committee. It is actually headed by the Minister of Health, and you have all stakeholders possible. And then you go into, we need one person who will be in charge of the whole screening program as such. We are now deciding upon this. Practically, it's not that easy because they are not everywhere, those persons being able to do that. And then you have for each, we're starting with 3 different screenings. We have already more or less the persons who will be leading breast cancer screening, cervix cancer screening, and colorectal cancer screening. We have chosen the 3 ones. We have already, a lot has been practically, for example, for the cervix cancer, the main issue is to have the right IT platform to bring the information from the onco register to the screening register and to all institutions that are actually involved. So this is another approach to the work we are doing, involving, I would say, the private sector. It was a self-government of the city of Liepaja. They have actually, we have more or less cancer curation, healthcare about cancer in Riga, but we have also in Liepaja and Daugavpils. And the city came with the idea that they would have to have a system to follow the fate of the women and foster a better health, better life to them. And they contacted a Latvian, actually I would say the best IT health company, Longgenesis, in order to have a platform where the women can answer to surveys and have some information about the probability, the risk of them to have breast cancer. What is interesting, as it is digital, the young women came to that and then they brought their mothers. So it is very efficient. It has been done now, the same thing at a wider level, and we have about 13,000 women who have voluntarily engaged into this initiative. This is about communication in screening. You know that it is a very critical point, and if you take the old-fashioned way of sending letters, you have only partial answers. Maybe this new way of reaching out to young women and then they bring the older generation is a part of a solution. The second project I am dealing with is the digital transformation of the Children's Clinical University Hospital. You see in the middle those are portals for the patients, for the families, for the competencies portal for the students, the researchers, and then for the family, the orange one on the top, it's more the families of children having rare diseases. They are very much isolated and they have to be in contact with the rest of the world. And then what is new and to which I put a lot of myself of efforts is the E and F. It's about, we have received a donation of 20 million euros, plus there will be other international financing. It is to have a health advancement center where we'll have a new pathology laboratory, but also what was described before, simulations, teaching, giving skills to medical doctors or to young students. And our aim here is actually to foster the cooperation with research. Traditionally, healthcare was curing people, and we know now that the data that have to be given, this is patient 360 means that the young children will be followed, there will be information before, there will be information after. It is, you go from electronic data to more holistic information about the children, and you can follow also until the age of 18 what they are doing, and then the data should be given further. This is the philosophy of the hospital, but then to bring research into precision medicine, there is one of the aims. So we are organizing mid-October an international conference, Precision Medicine Network, and we are intending to foster this narrowing the gap between the production of data and the use of data in research. The aim here is very classical, partly seen in others. One, you see clinical decision support system. This means that you need now, you don't have only consilium between doctors, but you need actually deeper insight in cancer cases, and you need then relationships, and it's practically also infrastructure to be in contacts. We have a strong cooperation in Northern Europe, starting with especially Helsinki, but then you have to have the technology at the quality level that is also abroad in those hospitals in order to be exchanging and to decide in a molecular tumor board, for example, that what is the diagnostic and what the treatment should be given. Follow-up systems is, I have nothing new to say. Part of it I have seen today already. I don't want to repeat it. But what does it mean? It means that what is called now, I've learned this, data collaborative. Data collaborative, we were talking about those data quality, the infrastructure, the standards, and cross-boarding of health data. So here we are getting, and I suppose in Romania as well, involved in the European health data space. It's not easy. They are preparing a regulation on this, and believe me, they are not close to the aim. So we are also working on the legislation in Latvia. It's in order for us to be able already to work properly now. But there will be, they're asking in Brussels to have a node in each country. It will be an institution that is able to deal with the data. We are working with Finland, there is FinData. It's actually remarkable what they are doing. We don't have all the capacities they have, but we are aiming at that. And I'll be finishing with 2 use cases because they are open to cooperation, and it's typically data collaborative. One is this data collaborative of health data space. It's gastric cancer and precancerous lesions. This is a project that has been presented to the European Commission, didn't get the financing, but it has been chosen by Gaia X, and Gaia X is an association at the European level fostered by Brussels, where you have they are fostering the capacity of sharing data, so according to all the criteria we have been saying, at a European level, and it is also concerning health data. And Latvia, in this case, has a leading role, but we have partners, strong partners in Portugal, and Slovenia, and France. This model you see is a very classical one, but what is not there classical, that Gaia X is aimed at medical data research and the participation of the private sector. Here it is Microsoft. In principle, you see free access to the Caracol platform to scientists. It will be open, and not only to Europe, so to Europe anyway, but to the member states of the European Union. It will be, as you said before, the quantity of data, it's never enough. So it is more than important to have the right information about the early stages of this cancer. They are volatile indicators of the presence of the cancer from the patients, and it will be shared all around. It can be shared all around the world. And this is another, I suppose Romania is there as well, yes. This project is about, so it's written comprehensive cancer infrastructure and comprehensive cancer care networks. It is led by the Organization of European Institutions on Cancer. It is to promote, you have cancer registries, cancer centers, and in order them to be modernized and to be actually also gathering or coordinating, let's say, cancer data use and research, there is an accreditation all over Europe on the quality of the system, whether it fits to the CCC, Comprehensive Cancer Center. We are not yet there in Latvia, we are on the way, but you see that we are on the map, and Moldova is on the map, and speaking this project has been submitted, and the head of the OECI is actually, OIC, Simon Oberst is also dealing with Latvia in our previous project, and he could see very easily that Latvia would work especially with Moldova if it is needed, if you wish it, and if we find the ways to do it in the future within this frame. The idea is that there would be a coordination of all cancers systems all over Europe that would make the system compatible, again for the same, so gathering information, and why not to have a European metaverse? I don't know. So we'll talk about it. Well, thank you. That's what I...
Thank you very much for this excellent presentation, and I think it was nicely complementary, because you've seen data in real life. Latvia is clearly more advanced than many other countries, and congratulations. And fostering, let's say, pilot studies, I'm envious, with good quality envy. And if there are questions from the audience, maybe to see how we can foster this cooperation and so on, so please. What are in fact the possibilities to join? Is we write to you directly, we write to... There are platforms in the European Union legislation, or how?
About this CARECOL, about the second one. This is the second one is already a project. It has been submitted, so everybody is there. Mm-hmm. But the CARECOL, yes, you can write to me. I'm directly linked with the Latvian leader in this, and I am the history. I mean. You know very well that you have the aim, let's say we have metaverse, but there is the reality outside metaverse, and in Latvia we are not yet there. You are, I call it, we are at different historical cycles. So you have the modern medicine, but you have people working in the past, which is not obligatory a bad medicine as such, but you can't promote everything at the same time in the medical system. It's impossible. So we are not as good as we are, but we are working, and we try to be, Professor Klovinch will tell you also about his activity. We are trying to speak, to work in an integrative way. What I wanted to show is all the problems that you have, because you are living in the past as well as in the future, and you are trying to do everything in the present. I think in Romania you must be, you're not yet in the metaverse, but it is where we have to aim at. I suppose so.
Yeah, I think what we've seen, and I'm coming back to real life, for example, in the COVID pandemic, we've seen that there are countries with specific legislation forbidding to share clinical data. For example, Germany is one of those countries, and you can imagine that if we have a huge database without large countries such as Germany, it's a nightmare. How can you comment on that? The EU is trying to change that, or?
Well, yes and no. They were surprised. We have in Uppsala a Latvian lawyer who is specialist in health data, and she was telling Brussels that you don't realize how fragmented the whole system is. Because as you said, the GDPR, for example, the regulation is, it is forbidden to give data about health and or patient data because you protect them. So this is done. But for research, it is, as you know very well, an obstacle. And then they are relying on the national legislation, but political initiatives as well to deal with this issue. And the result is a total fragmentation. This is, so Germany, we are working with the Swiss, it's a Swiss financing instrument. It will be on pediatric oncology, 7.5 million. But our first idea, which was precision medicine and genome sequencing for all, we have about 50 new patients every year, children patients in oncology. It could be possible to make a genome and to analyze the mutation, but in Switzerland they don't do that. It's forbidden to do that, and because of the referenda, it would be quite impossible to promote it. So they were very reluctant. Well, they are not in the European Union, but it's the EFTA, and this financing is because of the European Union. So the answer is, to what I understand, in Latvia we have to proceed with our own legislation, which we, and it's in accordance with the EU regulations, but they are relying a bit on us. Frankly speaking, if Romania comes with their own legislation making sense, they will accept it and they will be actually happy. So it's a bit on our side, national side, I would say.
Okay, thank you. Any other questions? Please, Professor.
Thank you very much for a very interesting presentation, not only for presentation, but for this big work that you've done, all this integrity for assessment, analysis, and establishing country this system. For us, for Moldova, is big perspective the merit and includes in our country. I have one question. I know in Latvia it's a higher level of firefighting. Tell me please, do you have same connection between all these projects, the cancer project or oncological another project with biobinding, and how it's all together?
In that case, I will leave it to Professor Klovinj, because his institution is having the biobank, and they have been welcoming your professor, who is going to be responsible in Moldova about it. He will respond much more cleverly and properly. I am a former diplomat. I'm able to talk about anything, and even better if I know nothing about it. But there, in his presence, I would feel very badly. So,
thank you very much. Thank you for the excellent presentation.
Thank you.
And
mulțumesc. No?
Cu plăcere. So it's my pleasure to invite Professor Jānis Klovins, head of the Scientific Council of the Latvian Biomedical Research and Study Center in Latvia. And he's going to discuss with us both answers to some of the questions and, in fact, about the citizen science as a key element of a future biomedicine, the Latvian experience. Please, you have the floor, Professor.
Okay, first of all, I really would like to thank organizers for being here. I enjoy, so far I'm really enjoying being here, and I'm really happy to hear the other lectures, and this is, I guess, an excellent meeting that we can exchange all the information together. I will not start answering the question. I will rather incorporate it into my talk and when I come to that. Okay, and I'm really happy that actually we had these first lectures, and my presentation is already a continuation of what was discussed before. And thanks to Professor COVIC, actually I would be able to skip some introductory slides, but still, so I will go on. But I'm looking on this future medicine from the different perspective, because we also know that in all stages of the research and then applying this research, there is citizens involved in this process. So, and then since the landscape of research changes, it's also very important to understand what are the perceptions from the general public, from the participants of the research, and this is a key element for us to build this future research. So if we look at the history of medicine, that indeed in the past it was more like intuition medicine. So the treatment was based on experience, and I would say it's actually based on intelligence, not artificial intelligence, but intelligence of the doctors that really were well trained. But the problem was that the amount of data for each patient was really limited. So basically you have only signs and symptoms. Now we, as already was discussed before, we have evidence-based medicine, which is really based on the knowledge, on the strict clinical trials that produce specific guidelines. And if we look at the future, and precision or individualized medicine, so basically what we expect that artificial intelligence or algorithms will take the place to help us to really decide for the individualized treatment options. But if so, let's see. So basically, in a very simple way, how that works in our days practice. So, for example, if you go from the patient, you have a diagnosis, you have to follow the guidelines, you select a drug, and for example, if it fails, you go to the next drug, and so until you reach the success, hopefully. And of course, these guidelines are based on very specific clinical trials. And what we want to expect from the future medicine, that instead of that, we would have this artificial intelligence, which uses a huge amount of the data coming from the patient, like starting from the lifestyle, clinical data, also including some omics data and even sensors data. Then first thing what we need, that the diagnoses are much more precise than previously, and then of course that we automatically select the right treatment for the patient. And already in this setting, you can imagine the classical blinded clinical trials are not that suitable because there are too many different options just to go through this pathway. And even more, what we would like to have is instead of diagnosis, we would like to predict the risk of disease. And again, so to predict the risk of disease and also try to select the prevention programs for these specific individuals that would prevent disease. And imagine in this setting, it's even more difficult to operate in a classical clinical trial setting, so you need something in place. And to have that in place, you have patients to be, or general public or participants of the research to be involved at the different level and more interactive level. So what would be the requirements to establish these precision medicine methods? So first of all, we are talking about the viability of large data sets, and that is not only coming from the clinical setting, but this is also real life data, sometimes from sensors. That means that the citizens or people should be really involved in this process interactively. This is needed to enable calculation of this individualized approach for prevention or treatment. And even more, we also need the real-life feedback from the people to really evaluate the efficacy of some intervention and to really not only to judge the intervention, but also to improve these algorithms. So basically, this can be facilitated by the access to health data. The biobanks play a very important role here, at least at the research level. So basically, because they have already accumulated the results and research data on individual patients. And finally, this is the main subject of my talk, that you have to have dynamic interaction with the research participants. And that involves also reporting back the research results, and you really have to understand what people are expecting from this and how to perform that. So I would like to first introduce my institute in one slide. So I'm coming from the Biomedical Research and Study Center, which is the largest institute dealing with the life sciences and biomedicine in Latvia. And we are also responsible for operating the number of national infrastructures and the genome database of Latvian population, or National Biobank is one of these infrastructures. We also represent Latvia in a number of international organizations, including the European 1 Million Genome Initiative, which is a really great initiative to deal with many of the problems that I was mentioning. So a few words about the genome database of Latvian population. This is in operation since 2006. This is one of the largest biobanks in Eastern Europe. We now have around 40,000 participants. Biobank includes many targeted studies, and this really became an infrastructure resource for scientific research and international collaboration. We also collect the genotyping and different omics data generated in our databases that are available for researchers. And we have developed the data retrieval system for national health, from the National Health Information System, so that we can join together these data. We also are national node of BBMRI ERIC that really enhances both the local, because we also developed the local network, and this is maybe the answer to the previous question, that how we try to implement these principles from the BBMRI ERIC to really join different biobanks together. And talking specifically about this cancer biobank, actually we have very good collaboration, and this is joint effort, because there are part of these samples, like pathological samples or slides and things like that, are stored at one position, and then we are responsible for keeping the, for example, DNA or sequencing results. So it's a really mutual collaboration. So to really go and understand what is the public awareness and how the public, and not only public but also different segments really perceives this research, we performed a study where we did a survey on 3 domains. So first of all, we questioned the general public, then the actual biobank donors, the people that were involved in national biobank, and finally, what are the researcher options on all these aspects. So since we have done the similar survey in 2010, so we also were able to compare these results, how the things change. So the one conclusion from the general public from the general public domain is that in general public awareness is still on biobanks is still quite low. Although this survey is done in 2019, and I think the COVID situation really has increased this. I would be rather interested what is the answers now, because people heard much more about our situation, our research. So I don't know. Probably we have to repeat it in some time again. But most importantly, when we compare the willingness of the people to really contribute for research, it has increased. Previously it was 25%, and now it's 36%. Comparing 2010-2019, we see its trend going to the right direction. And broad concept or broad consent is actually in a very fundamental principle in biomedical research in biobanking, because what we want to have is not only samples donated for this one research, but so we can use in the future. So, but when we ask this question to the general public, you still see that most of the responders prefer this narrow consent rather. So there is we have to deal with this situation and to explain to the public and maybe find other ways how to ensure that this broad consent is implemented in the right way. Interestingly, that from the actual participants of Biobank, the situation was a little bit different because they already dealt with the process, and most of the donors actually acknowledged the broad informed consent. In some cases, they even mentioned that they don't want to be bothered for the additional consenting, so it's quite okay for them to have this broad consent. And when they were asked about their views on the dynamic consent, which means that actually so the people can in a real time follow up the research and also opt out the agreement to the research. So this is something that was received in a very good sense. Another thing is, of course, the reporting back the research results, which is a very difficult topic. It has been always very discussed in the biobanking community, whether it should be done at all and how it should be done. And what we see from the participant survey, that most of the donors actually really want to be informed about the results that are important to their health. People are with a higher motivation to support science would like to obtain the results in their even email, but also admit that they would not fully understand the results. And still the motivation to obtain individual results is to acquire more information about themselves and to use this information for the health improvement. When we ask the question whether the people want to have the information about the untreatable conditions, they were actually really split between the answers. So basically part of the participants answered they really would like to know that. You can also see this even in the individual answers that, for example, yes, I want to know, I need to prepare everything for my children. And the opposite, that if you can't do anything with your to prevent this situation, so you did not want to know it. So again, it's something to learn from these answers, how we should present these research results into the reporting back. And of course, when you ask the researchers, they are not that optimistic with the reporting of the research results. The researchers agreed that communication of findings should be done, but avoiding daring statements. Some of the researchers were in favor of individual result reporting, some against it, but many researchers actually agreed that this is not their responsibility, that actually there should be a regulation in place that, for example, in our case, that this reporting should be clearly regulated in the new biobank law so that you know how to proceed with this situation. And but basically, again, this possibility that we would develop a system which would allow for the opt-out option, interactive, dominated in many answers also from the researchers. So what we took, from these surveys and are now trying to implement is actually a number of activities. Already in 2015, we developed and tested a mechanism for reporting back medically significant findings. For example, in that case, that was we were testing mutations causing hereditary hemochromatosis. We identified 14 carriers that were invited to the genetic counseling. And to our surprise, actually, what we realized that the response to attend this genetic counseling was really low. If I remember correctly, only 5 people showed up. So basically, that means, again, that you need to, even in this monogenic disease case, you need to have a system in place that is more followed up and our recommendation would be to implement such a reporting mechanism in e-health system so that the family doctors can access it and so on. This is what comes out from our experience. Now we're in a process of implementation of project Decide, which is a dynamic information system, which means that the people supposedly in the e-health registry, they can really first agree to the participation of in different studies. They can also withdraw this agreement, and they can see directly in which studies they are involved. And if there is some aggregated research data, they can really look at that. So this is one of the ways how we deal with the how we propose to report back these research results. Actually, we are also trying in some studies where we ask the participants if they would agree or they are willing to receive back not the medical consultation, but really some basic reports on their genomics or some others like microbiome composition, and this is really well received, and we haven't ever get a problem with understanding, because we are not providing concrete recommendations, but just very basic information. And finally, all these knowledge and information from the questionnaires are now implemented into development of new biobank law, which is already mentioned, and we hope that it will be soon accepted in Latvia. Since we have the quite integrated biobank that is quite integrated into the also research system, and we have ability to do the sequencing and also collaborate with different medical institutions and industry, we decided to try to run a study which we called Latvian Microbiome Project, really to test whether we can also involve citizens in more interactive way. So basically, this is the Latvian Microbiome Project is population-based citizen science effort, where dynamic human microbiome and associated lifestyle data collected into the platform and then used for different purposes, also including reporting back some results to the participants. And you see that we have developed the internet site for that, also detailed instructions how to collect samples and so on. And to explain more what happens in this system is that participants first they can apply. Importantly, as in many citizen science projects, they actually cover part of the expenses of this research. They collect stool sample, provide health and diet information into the system, and they also are invited to participate in a biobank. So at the moment, what we are really doing with these data, with these samples, we perform metagenome sequencing from the stool sample, also genotyping of the participant's DNA. This information is entered into the data platform. We have developed a number of pipelines for the data interpretation. So far, we are providing back the results as an individualized report with some basic microbiome information. In the future, what we expect that also this information and system is available for the doctors, for dietitians, so that they can actually use this information for making actual recommendations to the participants, to their patients, and this is again can be also stored into the same platform. Just a simple example what we are reporting back. So this is the we call it GAT-IT, the system that we have developed in frame of this project. So the people can receive their own microbiome composition compared to the population, whole population's microbiome, the richness of the microbiome, some specific known species of bacteria or combination of these bacteria, and the individual results comparing to the population. Also the beta diversity, and interesting that with the accumulation of data, we actually are able now to, in this beta diversity pool, actually see the how the different diseases, if we include patients also, how the different diseases segregate. So it's a good visualization how each person can see whether the microbiome moves to the some disease direction, and maybe it's a good stimulation for them to do something with their health. We also report kind of most frequent bacterial species present in their genomes, and of course they all have also the viability to have total data they can also use elsewhere for different analysis. And this platform is not only to report back the scientific results, what we have in mind, and also some examples that is also working. This is a good opportunity to involve industry, involve health specialists in this system, and then most importantly also this is the kind of good platform for the developers of health IT tools to work on it and develop their products. So this is the whole idea of this citizen science related project. Interestingly, that we already have made an agreement with one private clinic that was very interested in having these data. So basically, they can use these microbiome data for their own patients to really helping to direct their decisions for the treatment, and in simpler cases for dietitians to provide better consultation. Interestingly, that also we have an interest from the company producing cereals with some prebiotics, and so in this case we use this platform as something that we can offer to perform some not exactly clinical trials, but trials to really invite people to participate in such evaluation of some foods and their effect on health. And finally, we have a lot of future goals to use this information for the gut functionality report, for the pathogen and antibiotics resistance testing, and for the genetic risk score reporting. So there is many things that we are going to implement in this system. And we also have surveyed the participants so that we understand how they perceive this information. And even though because we are not allowed to provide any health recommendations, they are really positive about these results, and then they can search for some additional health-related recommendations elsewhere, or use our collaboration network to really do that. So this is a few examples from what we are doing, not exactly in the clinical research, but in really trying to understand how the general public and participants understand this situation, how they participate, what are our expectations, and I think it is really important, and that help us to improve the biobank law, starting from the legislation and also practices that we are operating in a biobank. And I think if here in Moldova you are going to create a biobank and also to approve this biobank law, you should also consider all these aspects as well. I would like to thank everybody for the listening. Yeah, thank you.
Thank you very much. The floor is open for questions, discussions.
Practical question, but maybe it's good for everybody to know that. So, you show for us the huge team of the center. So, tell me please how they are paid. So, by contracts and by the permanent positions, or most of they are in the project?
Mm-hmm. Yeah, that's so. First of all, we are in Latvia. We are an independent institute, so that means that we are not directly associated to the universities, even though we really work with at least 3 universities. So we are serving a number of universities. Most of our our staff is also professors at different universities. So we are independent. From the funding perspectives, I think, yeah, this is indeed a huge problem, I think, elsewhere. Only 20% of our funding is granted from the basic or this subsidiary funding in Latvia. So basically, this is something. And the rest is achieved either from the research projects, from the competitive way, or agreements with the industry. So, of course, this is not a very good position because that does not create stability. Even though we are actually introduced a number of smart ways so basically support systems. I think all the money we receive for this from this basic funding goes to the support in cases to maintain the research groups if they are not that lucky with the research projects. So basically we manage to really maintain the integrity and so that the researchers are not going away every time their project ends. So basically we have the system in place. Yeah.
Back to the slide with the artificial intelligence and the processing of data. So then the question would be easier to explain.
You mean on this microbiome project?
Yeah, the second one would be
here?
Yeah. So my question is like this. Okay, the only you get from the hospitals, for sure. The rest of the data basically sits there in the smart devices of the patient. So lifestyle, existing conditions, even clinical data. There is an app for everything, right?
No.
Wait, there are apps, and people use it, okay? My question is, do you see the possibility of working with the industry to access that data? Have you had instances of trying to use that data? Because to my view, it's easier to say, okay, you have an app which measures your weight every day. You have a smartwatch which actually knows when you're sleeping, when you're not sleeping, knows when you're eating. If you're diabetic, you have an app for that too, which monitors the glucose levels and so on. And that data is there. So you see the possibility of working with the industry to use that to improve.
Yeah. Yeah, sure. First of all, this is a very simplified and kind of schematic representation, which is far from reality at the moment. But in this microbiome research platform that we established, that is exactly the goal of what we are going to have. And we already are in contact with some. Because of course it's also useless to make your own apps every time you design a new system, and we really believe that we can use already existing and most popular programs. Of course, it's not an easy step. We are in contact with some of these app producers that are used by public. And of course, there is also hesitation to of course, first of all from the legislation point of view, and I think these are the problems that has to be solved in the future. But I think, in a way, this is the most rational and I would say only way how we can work in that direction, I think. And I cannot give you an answer and say everything is working, but there is an interest. So, for example, we have at least now negotiating with 4 companies that are developing these prediction algorithms. Most of these are, of course, companies that are interested in your data. So basically, that's the situation. But it's also a deal, yeah. So basically, if they develop the product, I think that way, I have a feeling that it's going more easily than already well-established programs that have their data, and then it's more difficult. But this is exactly what I'm supposing to have these interaction with the industry and existing initiatives.
Thank you very much.
Yeah, thank you.
We'll have to move on. We are going to break for 10 minutes, and then it's going to be the next session. It's a little bit of a delay, so just 10 minutes, and see you here afterwards. Thank you very much.